Now let's talk about the ExOR gate. In this first experiment, we have to learn about OR, AND, ExOR, NAND, XNOR, different gates. So we will skip some of the gates. Okay, we will talk about only the basic inverter circuit, and then second one is ExOR gate. Okay. So what is this ExOR gate? It actually performs modulo 2 addition in the circuit. Okay. What is this? Input X and Y. It takes two logical input and give you one logical output. Okay, and this is the truth table of this ExOR gate. It is available in the package of IC7486, that is the 14-pin IC. Again, when both input is 0 0 or both input is 1, the output will be 0. It detects the difference. So you can see when this is 0 and this is 1, it will be 1, and when this is 1 and this is 0, this will be 1. This is high for different input. One should be low and one should be high. One should be high, one should be low. Then it will detect as high output. LED will glow when one switch is off and one switch is on, or first switch is on and second switch is off. So let's demonstrate this experiment in the Tinkercad. So let's demonstrate the working of this ExOR gate. So you can see this is 0 0 and output is, we will connect. Okay, so run this. As this is one input is high and one input is low, output is high, that is 5 volt. And whenever both inputs are 1, output is 0, that is approximately 100 microvolt. Let's see what happens if it is 0. It is again 5 volt. So you can see if there are difference in the input, if this is 1 and this is 0, this is 0, this is 1, output will be high, otherwise it will be low. If the same input is applied to the ExOR gate, output is low. So let's perform this experiment in the Tinkercad. We will again go to the circuit. Let's create a new circuit. So like in the last experiment, we first need a breadboard. So we will open all section and we will search for the breadboard. Here is the 840 pin breadboard we usually utilize in our laboratory. So we will drag and drop here. Scroll down to zoom out. Now we need a power supply. So here is the power supply. Like in the last experiment, we will first connect the power supply here, red, high voltage, black for the ground. Okay, so we will color this. This should be red, that should be, the second wire should be black. And now another thing, we will connect it to the another side, red, and this one is the black. These are optional, okay, but it is a better way to perform this experiment. So this one should be red and this should be black. You can see here this is connected, this one is connected. Now we need IC of XOR gate, that is 7486. So we will go to the logic section. In the logic section, you can see there is quad XOR gate. Quad, that means there are 4 XOR gates available here in the 14 pin IC. This is 14 pin IC. You can see this one is the ground. This should be the power. Okay, so we will connect it to the power supply. Make it red. We will connect this pin number 7 to the ground. Make it black. Again, we need switches. We will use this SPST switch. Now we need 3 registers. One is for this, 2 for this switch, and one is for the output LED. Okay, so we need 3 register connected to the pin number 1 and positive supply. Second register connected to the 1 and positive supply, and third one is needed for the LED output. So here we will connect this to the first input. We will connect to the second input, and third one is the output. You can see here input 1, input 1B, and this is the output. Okay. So let's change the color. We will use orange and blue. Orange and blue as input, and green should be the output. We will utilize, we will connect it here. Okay, so now this portion is completely output. We need an LED. So here is the LED. We need it to rotate it. Click here, rotate. Connect it here. Anode portion is connected with this wire, and now we need this resistor. Now connect it to the ground. Make it black. Okay, I think connection is completed now. Okay, no. The switch portion is incomplete. So you connect this it to the ground, this side. This one is also should be connected to ground. Now the switch portion is also completed. Make it black. Okay, black. Okay. Now the connection part is over. Now we can start our simulation. Now you can see the switch is off and the output is 0 because the LED is not glowing. Let's make one of the input as high. You can see the output is high, LED is glowing. Now make another switch on, LED is not glowing. This is 1 and 1, high and high. And now make another switch low. Again LED is glowing. So you can see this IC performs ExOR operation. If any of the input, if both of the inputs are same, output is low, LED is not glowing, and if if both the inputs are different, LED can be glued. So you can again utilize multimeter to see the input and output pattern. Now we need 3 multimeters. One is for first input, one is for second input, and third one is for output measurement. Okay. Now first connect all to the ground. Black portion should be grounded. This negative portion should be grounded. So we will connect it to the ground first, and now this should be connected to the first voltage applied, that is here. Make it red. Second input, that is available in the blue wire. Or you can connect it here. That is also should be red, and this should be the output. So we'll connect it here. So it is sorted with this third pin. Make it red. Now we will see our simulation part. Now you can see this one is 5 volt, 0 volt, and output is I. Now make changes in the switch. 0 volt, 0 volt, output is 0 volt. 0 volt, 5 volt, output is 4.87 volt. 5 volt, 5 volt, and output is still 0 volt. So this is all about the ExOR gate operation. Okay. So in this way we can complete our experiment number 1.